All right, guys, here we go. We're on to chapter 9. So we're going to extend off of the confidence intervals, and we're going to what's called significance tests. So the real quick idea is this, is that the confidence interval, just so you guys know, a confidence interval said, okay, like if we had a normal curve, where likely is my true parameter? So like this would be a 95% confidence interval here. And so our true parameter or our true population would land in here, right? So this is where our true population is, or our true parameter. 95% of the time, let's say, parameter, okay? So then, from there, well, what are these guys out here? These are areas where the true parameter doesn't lie. These are the ones that are statistically significant. These are the ones that are completely different than the true parameter, and that's where a significance test is. So basically, we have this claim that's made against the parameter, so it's against this without any data. So there's no data involved whatsoever. It's just like, the height of Exeter High School students is not 65 inches on average, okay? So I'm making a claim against the parameter of heights, and then I go out and I take a sample, and then a sample suggests it's not true. So we're going to say, oh, well, the sample is going to suggest it's not true. So I'm telling you it's not true. Now I'm going to go take a sample, and I'm going to suggest it. So we have to decide what that claim against is made. We have to decide two things. That the claim is true, that the claim, the true difference is by random chance. So it falls inside, so that the claim, did I get these backwards? The claim, I did. This is not true. No, I wrote it up wrong last night. So the claim is not true. It falls inside, and then the claim is true, and it did not happen by random chance, and it falls outside. So this whole idea is that random chance is right here, and outside of this is not random chance, so the claim against it is true, okay? So that's kind of where we're going. Is it going to be statistically significant that it's not true? That's why it's called the significance test. How significant are your results? And do they say that a claim is true or not true? We don't use that type of language, but we kind of work within those confines of how it works. So, how do we set it up? Well, we state a hypothesis. That's the first thing. We state a hypothesis before we do any data. Before we look at anything, we just make a claim and we state the hypothesis. So, for the null hypothesis, it is the statement of no difference of the parameter. Remember, all hypothesis is all about the parameter. So we're either using mu, or we're using sigma, or we're using p for population. We're dealing with parameters only in the hypothesis. And so the statement of no difference pretty much says the parameter is going to stay the same. The alternate hypothesis is what we are trying to find. So for my example here, the statement of no difference would say something like the EUHS heights, average height of an EUHS student is mu is equal to 65 inches. And then what we're trying to find, it would say the alternate hypothesis would be something like the average height of EUHS students is greater than 65 inches. So we were saying this is the different statement. What are we saying is different than the original one? And you must use parameters. Always has to be parameters. All right, guys, let me look at what we got to move on. Okay, so there's two more things I've got to cover real quick. And so if we erase this, sorry on the video guys, got to erase things a little bit so you can make little notes, ask questions, whatever you need to do in your brain. So let's look at this. There's three types of tests. Well, there's two types of tests. There's a one-sided test, one-sided. So it's going to be like, I want this side, or I want this side, and then there's two-sided. There's this, or there's this. So this is a one-sided. I'll change colors, guys, because that's probably not coming up very well. There's a one-sided test and a two-sided test. So one-sided tests state stuff like the words less than. So like this one would be less than. So we know it's less than. This one would be like greater than. So anything that has words like greater than, less than, more than, all those types of things would be one-sided tests. Two-sided tests would say not equal to, or is different than. So different than means it can be less than or greater than. So we got a one-sided test, and then we've got our two-sided tests. Okay? So if we're looking at different pieces like that, you can use the word changed if you wanted to. Mu has changed. That is two-sided, meaning it's different. So just kind of watch the wording, and we'll work through a bunch of different ones. All right, so let's just tackle the quick example we have here. All right, so on that first one, describe the parameter of interest. So if we look at the golf example, the golf example talks about golfing, and it talks about a hypothesis. So first of all, describe the parameter of interest. He's using his old 7-iron. He hits it 175 yards with a standard deviation of 15. He is hoping that his new clubs makes his shot on the 7-iron more consistent or less variable. When we're talking about variability, we're talking about standard deviation. So Mike is interested in the standard deviation of his golf club. He wants to be more accurate. Remember, accuracy has to do with standard deviation, how far it lands. Well, how far is he talking about it? He's talking, so it's basically, that's the parameter of interest, the standard deviation of his drives. That's kind of when of his drives, of his new golf club, the new 7-iron. Okay? That's what he wants, because he's normally hitting it 175 yards. And then normally, he has a standard deviation of 15 either way. Right? So he has a standard deviation of 15 either way. He wants to know if he's going to be more accurate. So he wants to know if it's going to be what? He wants to know if standard deviation is going to be less than 15 degrees. 15 feet, or is it yards? Sorry, it's 15 yards, 175 yards. He wants to know if sigma is going to be less than 15 yards because he wants it more accurate. So that's the idea. Is it going to be more accurate than there? So what is our statement? First of all, it's a one-sided test, right? Because it's less than, so we know it's a one-sided test. Secondly, our null hypothesis, which is H naught, they call it H naught. Our null hypothesis is the 7-iron sigma will be equal to 15. Statement of no difference. It is no different than the original 15. What's our alternate hypothesis? The 7-iron standard deviation will be less than 15. There's a basic null hypothesis and a basic alternate hypothesis. Because he wants to be more consistent, so he wants it to be smaller than 15. All right, guys, there's your first set of notes for the week. Have a good one. Good luck with the assignment. We'll see you soon.